So here we want to discuss the overall goals of GATE and how it applies to clinical practice. So we first notice that when we look at GATE, the trunk essentially becomes the passenger and the legs do all the locomotor work. So this is how we get that Bugs Bunny look when we're walking. Now we can break down the trunk movements though into superior, inferior, medial, lateral, and anterior, posterior directions because they essentially aren't zero. So even though we treat it as a passenger, there's still some cost in terms of moving the trunk. And we can relate the movements to different kind of overall therapeutic goals. So for example, minimizing superior inferior movement helps with energy conservation. Also minimizing medial lateral movement also helps with energy conservation. And then our ability to do single leg stance during medial lateral shifting and also has to do with balance, and then our ability to really take big strides and increase cadence, which is kind of anterior posterior displacements, is what moves us forward. So that's our forward progression. So here's a recent study that looks at how much trunk movement's occurring during gait. We have thoracic spine angles, so the chest relative to the lumbar spine, and then the lumbar spine relative to the pelvis here, and the three different planes of motion. We can see that essentially in the sagittal plane, there's a very small amount of angular change. Here's 10 degrees, so we're talking 2 to 3 degrees on offset, and then just a degree or two oscillation in the sagittal plane of the thorax, movement on the trunk, and then similarly of the lumbar spine. In terms of the frontal plane, there's a little bit of medial lateral leaning, but again, it's only a few degrees, and so this would be visually very difficult to pick up, although we do need to pick it up when it's excessive, as for example in a Trendelenburg gait or something like that. And then we see in the lumbar spine a real consistent, just change in lateral flexion from a few degrees during the double support, as we're transitioning from double support to single support. We can see that's occurring symmetrically on both sides. And then in terms of rotation, there's actually quite a lot more relative to sagittal and frontal plane and within the spine. So there's upwards of five-ish degrees of thoracic rotation in lumbar, and a few more degrees in thorax and then lumbar, which then gives us that kind of twisting motion when we walk. So essentially, it's safe to say that there's not much motion coming from the trunk during gait, so this is how we perceive of it as a passenger, and that essentially the goals of gait are balance, forward progression, and energy conservation. The balance challenge comes when we start single limb support, and that's often involved in neurologic and gait problems when people have weakness. And so it's shown here in the frontal plane. Forward progression is all about gait speed and achieving an adequate cadence combined with stride length to be successful. And then energy conservation is about how smooth we give the passenger a ride. So how smooth of a ride can we give the trunk, and some measurements, for example, that are fairly impressive, and how we achieve a smooth ride. Normal gait is the vertical movements of the head are around 5 centimeters, and the side-to-side movements of the head are around 4 centimeters. So that's a pretty smooth ride. And that's it for goals of gait and trunk movement.